All right, we go over a exercise which is applying the binomial distribution. All right, so this is the first exercise. All right, so a fair coin is tossed n equals 3 times. So a fair coin has, it's like a quarter, has heads and tails. First, we're going to draw a box showing the possible outcomes. All right, so what I mean by that is just, here's heads and tails, here's the box. So this is called a box model, and a lot of problems with probability can be put in this format. And so this is as if we are drawing with replacement out of a box, and it has like tickets or marbles, and they have two choices, heads or tails, and they're equally likely. But you know, it's flipping a coin, but it's the same model as if I put in two marbles. One has H on it, one has T on it. B, what is the probability of tossing in this order heads, heads, tails, heads, tails, 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 heads. So it's a lot of stuff. All right, so I better have gotten that right. Okay, so it's HHT, HTT, TH. Okay, so we've talked about that when you have a single event, but it involves one thing happening after another, we multiply the probability of the first thing happening, which is the probability of heads, times the probability of the second thing happening, which is also heads, and then the probability of the third thing happening, the probability of the fourth, etc. And because we're tossing a fair coin, the first toss does not affect the second toss. So therefore the coin tosses are independent. So when we use the binomial distribution, we look at independent events that follow each other. Now, we can look at the model or just look at this box or whatever way we want to think about it. There is a 50% chance that we get heads, because there's one heads out of two possibilities. And then heads again, a half for tails. So in this case, the probability heads is the same as probability tails. And we just keep going. The thing is that I have to be careful to not write too many. 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And this can be written as 1/2 to the 8th power, or 1 to the 8th, which is 1 over 2 to the 8th. And then whichever way you can use a calculator, I just remember that 2 to the 8 is 256. So that's the probability of getting this exact lineup. If I asked what's the probability of getting 5 heads in a row, this would be the answer. So it's on, I mean, because it wouldn't matter if I had any lineup, heads, tails, or anything. It would be the same answer because heads and tails have the same probability. So let's just write this as, by the way, the probability of, okay, 1, 3, 4, 5, 6, 7, 8 is also 1/2 to the 8th power, which is 1 over 256. So it's pretty unlikely. So if you see a head, if someone's tossing a coin and it's 8 times head, you start thinking, well, hold on, is that a fair coin? But it could happen.